Hi, hello, my name is Kiran Kumar. I am your physics lecturer. Today topic is a relation between the phase difference and path difference, and also we will discuss variation of the phase with time. Welcome to my channel Nature of Physics and Art. Considering here reference circle. For this x dash is a diameter and y dash is also diameter. These two are mutually perpendicular to each other. Now a particle which is moving with angular velocity omega in anti-clockwise direction. Okay, so initially here t time which is equal to 0. Okay, whenever the particle reach from the x to y on the circumference, it reach time t is equal to capital T divided by 4. Okay, so then here the particle is continuously moving from y to x dash, and here time taken t which is equal to t 1 by 2. See this 1 by 2. Next, continuously moving from x dash to y dash, here t which is equal to 3t by 4 from x to y dash, and here small t which is equal to capital T. Okay, for one complete rotation. When the particle moving on the circumference of the circle, it is doing simple harmonic motion on the diameter. See here x to y on the circumference, on the diameter, that is from the x to O. And if it is move from y to x dash like this, and x dash to y dash, that we can consider like this, and here from the y dash to x we are considering like this. Here one complete rotation which is time taken is equal to the time taken to complete one oscillation on the any diameter. Okay, this wave graph here on the y-axis considering displacement y, and on the x-axis, okay, that is time, that is taken as time. Here O is the origin. Here the particle is moving from O to, what is that here? O here I am considering as a x to y here, then y to x dash here, then x dash to y dash here, and y dash to x, this is the location is x. See here time taken we can discuss from x to y is t by 4, and x to x dash is t by 2, and x dash to y dash is 3t by 4, and x to x, that is time taken to complete one wave, is taken as time period. Okay, so we can discuss like this. When the particle moving on the circumference of the circle, it is doing simple harmonic motion, and angular displacement also we can discuss here. When the particle move from the x to y, it is doing 90 degrees angle. Okay, so if the particle is moving from x to x dash, that we are considering like this, that is 180 degrees. Okay, if the particle is moving from the x to y dash, that considering like this, that is 270 degrees. This is the point O. Okay, so here considering O, and one complete rotation like this, one complete rotation that is taking as 360 degrees from x2, again reach that same position, one complete rotation, their angular displacement is 360 degrees. Here we can write like this, we can write the values. Here we are discussing the time and also angular displacement of the wave from the origin O. Now wavelength, the distance between the two successive particles of the medium is called wavelength. So here wavelength is lambda, like this we can consider. Here this is lambda wavelength, and angle already we did from here to here 360 degrees, that is we can take 2 pi. So here this is 2 pi. See, considering this is the path difference. So here we are writing phase difference. Okay, see, phase difference. For this, path difference is lambda taking, and phase difference is 2 pi. Okay, see, 1 is equal to 2 pi by lambda, yes or no? Then continuation here, x which is path difference, and we can consider here phase difference which is 2 pi by lambda into x. See, so this is taken as phase different values for the corresponding diagram. So finally we can write here phase difference phi which is equal to 2 pi by lambda into x. Here phi is taken as phase difference, okay, and x is taken as path difference. Okay. Now a relation we can find. See, first one. Here phase I am considering pi by 2, which is equal to 2 pi by lambda into x. Here pi get cancel, x which is equal to lambda divided by 4. So this here we can write lambda by 4 wavelength. Okay, and next, that is second one, pi is the phase difference. Here pi, that is equal to 2 pi by lambda into x. Here pi get cancel, and x which is equal to lambda by 2, and this distance we can write as, that is a lambda divided by 2. Okay, and third one is 3 pi by 2, which is equal to 2 pi divided by lambda into x. Here pi get cancel, and here x value which is equal to 3 lambda divided by 4, that is 3 lambda divided by 4. Here the value is 3 lambda divided by 4. This is 3 lambda divided by 4. Okay, and next we can simply write, that is fourth one. See, 2 pi last, 2 pi which is equal to 2 pi by lambda into x. 2 pi get cancelled, where x is equal to lambda. Already I wrote. This is the most important relation of the wave. Path difference, phase difference, time period relations also we did. Now we will discuss the second relation between the phase difference and path difference. And here we are considering two positions from the origin P1 and P2 at a distance x1 and x2 respectively from the origin O on a wave. Okay, see, for the x1 position, the phase is considering as phi 1. Phi 1 is equal to omega t minus kx1. For x2 position, phase considering phi 2, which is equal to omega t minus kx2. Now, path difference, phase difference relation, that is phase difference which is taken as phi 2 variation phi 1, then phi 2 variation phi 1, this is equal to k into x2 minus x1. Here variation is taken, difference is taken. Okay, see now, k which is equal to 2 pi by lambda, k is equal to 2 pi by lambda, then the resultant equation phi 2 minus phi 1, which is equal to 2 pi by lambda into x2 minus x1. Then we can write delta phi, which is equal to 2 pi by lambda into delta x, or we can write phi which is equal to 2 pi by lambda into x. This is the lambda wavelength between the two successive particle, and corresponding phase difference is how much? For this, phi which is equal to 2 pi by lambda into here path difference x, which is equal to lambda get cancelled. Here we will get phi is equal to 2 pi. How much here? Phi which is equal to phase difference which is equal to 2 pi. Try to understand. Here x is equal to lambda. Okay, see, whenever the path difference is lambda, then corresponding phase difference which is equal to 2 pi. Okay. See examples based on the given concept. Now, this is the wavelength lambda, distance between the two successive particles of the medium C. Okay, see, now this is also we can consider wavelength. Is there any path difference? There is no path difference. Okay, so here x is equal to 0 and phase difference also must be 0 because of phi which is equal to 2 pi by lambda into 0 into anything 0. See, here this is the lambda. Try to understand, and this is taken as a lambda by 2. Okay, half of the wavelength. See, for this path difference is a lambda by 2 and phase difference we have to find. See, basic relation phi which is equal to 2 pi by lambda into x. Here phi which is equal to 2 pi by lambda, x is lambda by 2. Lambda get cancelled, 2 get cancelled. Here we got phi is equal to pi. So here phase difference is pi, that is 180 degree. Now next relation. See, here lambda is the wavelength. Here also we can consider lambda is the wavelength. This is the path difference between the two waves. Now phase difference which is equal to 2 pi by lambda into x value is here lambda get cancelled. Here we will get phi is equal to 2 pi. So here we are considering this is the positive cycle, that is crest, and this is trough. So here phi which is equal to 2 pi by lambda into x value is half of the, that is one crest, simply that is lambda by 2. This is lambda by 2. Lambda get cancelled, 2 get cancelled. Here phi is equal to pi. This is the phase difference based on the path difference. Here this is phase difference. Okay, how much here? That is pi is equal to 180 degrees. Here how much phase difference we got? That is 2 pi is the phase difference. Now variation of phase with time. See, this is the origin, this is the wave traveling on the positive x-axis. This is positive y-axis. See, I'm considering two positions. So P1 position, P2 position. Respectively, P1 position time is T1 and P2 position time is T2. So on the x-axis we are considering time. If T is equal T1, at that position phase we are considering, that is omega T1 minus kx. And if T which is equal to T2 at that time, see phase phi 2 which is equal to omega T2 minus kx. So now phase difference, that is phase difference phi 2 minus phi 1. So phi 2 minus phi 1 which is equal to, that is omega common T2 minus T1. So this is delta phi which is equal to 2 pi by t, that is omega into delta t. Simply we can write here phi which is equal to 2 pi by t into small t. Now one example. A wave of frequency 500 Hz has a wave velocity of 350 meter per second. Find the distance between the 2 points which has 60 degrees out of the phase. Second, find the phase difference between the two displacement at certain point of time 10 to the power of minus 3 seconds at a part. See, in this question here frequency is given. That frequency mu is equal to 500 Hz. And second one is velocity of the wave is given, that is 350 meter per second. So wavelength lambda is equal to V by n. So lambda which is equal to 500 divided by 350, 0 get cancelled, and lambda value is 0.7 meter. Okay, for the first one. Okay, so try to understand phase asking here, sorry, path difference asking. So phase which is equal to 2 pi by lambda into x, and where x is equal to phi lambda divided by 2 pi. Okay, and here phi value is given as 60 degrees. So phi which is equal to, that is pi by 3, then x which is equal to pi by 3 into lambda value is 0.7 divided by 2 pi. Pi get cancelled, where x is equal to 0.7 divided by 6, where x, that value is 0.116 meter. This is the path difference for the given question 1 in a example. And we have to find the second, that is phase difference asking. So here we know the wavelength lambda value is how much? 0.7 meter for phi which is equal to 2 pi by lambda into x. Okay, see here lambda value already we got here, and x value, that is x is equal to velocity into time. Velocity is 350. Okay, and time is equal 10 to the power of minus 3 second. Here time value given, the time is equal to 10 to the power of minus 3 second. See, so then x value which is equal to 0.35 meter. Okay, now phi which is equal to 2 pi divided by lambda value is 0.7 lambda into x value is 0.35. see, this value, this is 0.35, 0.35 get cancelled. Here phase which is equal to pi is the answer for a given question. Thank you.